Hello, everyone. I would like to welcome you to BIM and GIS for Civil Engineers, where we are for BIM and GIS for AEC. My name is John Sayer, and I am a Technical Marketing Manager here at Autodesk that focuses on civil infrastructure. I am excited to be able to present to you a snapshot of what you can do today with the Autodesk connector for ArcGIS, a history of the functionality from where it all started to current today. We will be going through a workflow of how it works in Infraworks, Civil 3D, and Map 3D. Then we will talk about what is up and coming. So let's get started. First, though, I'd ask that you read through the safe harbor statement. To start, the Autodesk Esri Alliance was announced at AU Las Vegas 2017. This partnership gave us the opportunity to improve the way our customers work and reduce inefficiencies. This was a key driver in bringing Autodesk and Esri together. We are at a point now of moving beyond integration concepts to begin realizing true benefits, making the Esri Autodesk Alliance real and not just something on a piece of paper. Both Esri and Autodesk focused the first phase of our work on delivering product-to-product integrations and product-to-cloud integrations. Beyond product-to-product and product-to-platform integrations, our two companies have also been researching and delivering on platform-to-platform integrations. Moving forward, we will continue to work with Esri and our joint customers to develop workflows that take advantage of our maturing integrations to add value to asset management workflows and connect to what cities want to do on smart city and digital twin initiatives. We believe that together we have the best solutions to solve customers' challenges. This is the state of the integration, starting with a focus on what Autodesk development teams have been focusing on since 2017, which is mainly new functionality in our hero products, meaning Civil 3D, Infraworks, and Map 3D, that connects Autodesk design solutions to the Esri platform, ArcGIS Online and ArcGIS Enterprise. This functionality is referred to as the Autodesk connector for ArcGIS. So let's take a look at the agenda for the next slide, showing how the current functionality works. In the next 5 short videos, I will walk you through workflow for using the Autodesk connector for ArcGIS inside of Infraworks and Civil 3D. This workflow will show you how to connect to ArcGIS Online from Infraworks and Civil 3D, performing SaveBack from Infraworks and Civil 3D, and publishing to ArcGIS Online from Infraworks and Civil 3D. There will also be other functionality and workflows shown that accompany these 3 things. Then I have included 6 What's New videos for Infraworks and Civil 3D and put them in order of release. You will see some of the same functionality in the previous 5 workflow videos, but this puts things in order for you, and more specifically, what features came out when. I will also take you through in a short video how this same functionality works in Map 3D. So just a bit of background before we jump into the first video. I referenced the City of Littleton data that we are going to connect to and utilize throughout all of these videos. So I just wanted to let you know that that's where I got the data and that's what we're referring to. We will highlight in this video connecting to data in Infraworks using the Autodesk connector for ArcGIS, stylizing and configuring the data in Infraworks, connecting to data in Civil 3D using the Autodesk connector for ArcGIS, and then we'll talk about and show schema mapping for pipe networks. Now we are ready to start using the data that we pushed to ArcGIS Online. We will start in Infraworks and will connect to the data using the connector for ArcGIS. We will be connecting to the same sanitary sewer data that I received from the City of Littleton. Once I select the feature layer, I can map the information to feature types in Infraworks so that the data represents what I want to see visually I can also preview the data visually to be sure I have what I want. Once the data has been added to my model, there's some configuration that I will want to do to represent the sewer correctly. First, if I switch to an engineering view, I will be able to see beneath the surface. This will help with visualizing the sewer lines as they populate. Next, I will configure the pipe's data source. This is the sewer lines themselves. I want to represent the actual invert information for these pipes, so I will map the correct attributes from the data in ArcGIS Online to my elevation from and elevation to inputs. I also want to see the correct size of pipe, so I will map the corresponding attribute to the X and the Y size to reflect the correct sizing. The last thing I will set up is the style of the pipe. In this case, I want it to be shown as a yellow pipe. After selecting Close and Refresh, you will be able to see the pipes populate and the correct invert elevations and the correct sizing, all coming from the attributes in ArcGIS Online. Next, I will configure the way the structures will look visually. In this instance, I want to represent the sewer manholes as a yellow circle. I also want to represent the size of the manhole from an attribute in ArcGIS. In this instance, I want to change the X and the Y size with the attribute part size ID. The elevation offset will be mapped to another attribute called depth. I will add the attribute and put a negative sign before it and show the manhole going down in the ground. This will match the inverts of the pipe. Once you close and refresh, the existing sewer is represented in the way that we want. You can see if we select one of the manholes that we have access to the attribute information that resides in ArcGIS Online. The same will be seen if we select one of the pipes in the model also. Now to Civil 3D. I can connect to ArcGIS Online and the experience feels much the same as Infraworks. I can select the same sewer information and view it in preview just like in Infraworks. But when we map the feature that will represent the data in Civil 3D, we can make the pipes come in as gravity pipes and the structures come in as gravity structures. That means on import, it will create a gravity pipe network in Civil 3D. With schema mapping, you are able to map attributes from ArcGIS to civil properties inside of Civil 3D. For example, the structure height can be mapped to the attribute rim elevation. And we can map the start and end invert so that the pipe comes in the correct vertical location also. Once the pipe network is created, you can select one of the structures and see that the as-built condition has been reflected in the structure. The same has happened for the pipe information also. We will continue the workflow in the next video by showing the functionality for save back changes to ArcGIS from Infraworks, edit attributes in Infraworks and save back to ArcGIS Online, refresh attribute changes from ArcGIS Online in Infraworks, and then save back changes to ArcGIS from Civil 3D. In Infraworks, if a change needs to be made to GIS data that is connected to ArcGIS Online, you can perform what is called a save back in Infraworks, and the change will update the feature in ArcGIS Online. For example, I moved this manhole horizontally in the model, then selected the data source and selected Save Back. When refreshed in ArcGIS Online, the manhole shows the location I moved to. The manhole has moved, but the pipes have not. In Infraworks 2020.2, the pipes will update if you make a simple change to any of the ArcGIS attributes. This can simply be selecting the attribute and hitting Enter. Infraworks then sees this as an update and the save back will perform correctly. The changes will then show in ArcGIS Online in the right location. This problem has been fixed in Infraworks 2021. You can also change the attribute information in Infraworks and then save back to the data source, and the attributes update in ArcGIS Online. Notice I will change the inside diameter to 3.5 feet and the outside diameter to 4.0 feet. I will repeat this process in the next downstream pipe also. Now when I perform a save back, the attribute information is updated in ArcGIS Online. To reflect the changes I just pushed to ArcGIS Online, when I select the pipe data source and refresh, Infraworks updates the size of the pipe to the recorded value in ArcGIS Online. In this instance, it is a subtle change, but it reflects accurately. If the pipe data was updated by a GIS analyst to reflect a change, Infraworks maintains that live link to the data. So with a simple refresh, the attributes that were modified will update in the Infraworks model. Remember, refresh updates the data from ArcGIS. The saveback command updates ArcGIS data from Infraworks. If you need to make an edit in Civil 3D, you can use the saveback feature in the same manner. I will move the structure horizontally in my model, then open my Data Source Manager to access my connections to ArcGIS. Only select the data source you want to save back, then select Save Back. This will push the change to ArcGIS Online. Continuing on with the workflow, in this next video, we will show you functionality for adding preliminary design elements, change the feature class, and then save back in Infraworks, and publishing data to ArcGIS from Infraworks. In Infraworks, a civil engineer can conceptually lay out a sanitary sewer line. Having rich existing conditions GIS data helps the civil engineer with this layout. In this example, it is key to know the existing location of the sewer line so that a connection with the proposed sewer can be made with confidence. Once the layout is in place, you now have the option of changing the feature class of the proposed layout so that it will inherit the attributes of another feature's ArcGIS attributes. This saves you time and allows you to add the necessary attribution quickly. The values in the newly added set of attributes can be modified and filled out. Then, since the feature class has been changed to a feature that is in the model, you can perform a save back to the data source and the new line will reflect in ArcGIS Online. Not only the line work, but the attribute information that was added in Infraworks also. When the view in ArcGIS is refreshed, you will see the newly added line and the same attributes as the existing lines with our updates to the attributes. The last example was just one example of how to get conceptual design into ArcGIS Online. In this next example, we will publish a proposed sewer layout as its own feature layer in ArcGIS Online. This allows a civil engineer to show the design intent by collaborating with all stakeholders from a central source of data. When publishing to ArcGIS, you have control to select all feature data sources or just specific features data sources to create a new feature layer in ArcGIS. This gives the civil engineer the flexibility to provide just the data needed to convey intent. When you publish to ArcGIS Online, it is important to add specific tags to the data being published. This will help everyone that will be accessing this data at a later time. Once the data has been published, you can instantly view the data in ArcGIS Online. Now, this proposed sewer layout can be consumed by stakeholders and design decisions can start to be made. We will continue on with the workflow in this next video by showing the functionality for publishing to ArcGIS Online from Civil 3D and visualize the design from Civil 3D in Infraworks. Now that we have a conceptual layout of our proposed sewer that has been published to ArcGIS Online, as one of the stakeholders in the project, I can connect to that data and bring it into Civil 3D and create a final design. I have the option to bring the data in as gravity pipes and structures, but this data is just for layout purposes and might not have all of the data I might need for a gravity pipe network in Civil 3D. So I can represent the sewer lines as feature lines and the manholes as points. This will give me what I need to start design. Once added to my model, I can see the conceptual layout visually, which saves me time as a designer. As a designer, I can take this conceptual layout and start my design by creating a pipe network. This process allows me to design the proposed sewer, selecting the parts I will use, the surface I will be setting the rim elevation to, alignments to follow, etc. Placing the manholes and pipe in Civil 3D is faster for me because I have a location that has been provided to me from ArcGIS Online. I can create the network, create a profile, and add my vertical design to the sewer very quickly. Once this has been approved as the final design, the pipe network can be published to ArcGIS Online so that it can be made available to all stakeholders on the project. This information could be used by a stormwater engineer, for instance, that might be placing inlets and pipe and need to know the location and vertical depth of the proposed sewer. Once published to ArcGIS Online, stakeholders can view and connect to the newly published design data. This is the design of our sewer, so this will help them avoid collisions and enable them to make good design decisions now on the utility they are designing, instead of having problems in the field. Oftentimes, a civil engineer needs to talk with all stakeholders about the final design of the project. Now that we have the proposed sewer in ArcGIS Online, we can use Infraworks to convey the design to all stakeholders in a 3D contextual environment. Sometimes 2D plans can be hard for people to completely understand. If the data is in a 3D environment, it makes it easier to show intent. We'll use the attributes for the design to accurately reflect the proposed manholes in our model. We will do the same thing for the sewer pipes, adding the designed inverts in and out, and show the designed pipe size all from the attributes in ArcGIS Online. With the actual design represented correctly in Infraworks, you can now see how it affects everything in the model. You can also access the structure information and pipe information directly in Infraworks. This workflow helps all stakeholders to better understand the project. Continuing on with the workflow, In this next video, we'll show the functionality for creating custom attributes using property sets from Civil 3D. And then we'll publish to ArcGIS Online the newly added attributes from Civil 3D. In Civil 3D, we have the ability to add what's called property set data. This is a great way to add additional rich attribute information that will be included when you publish to ArcGIS Online. In this example, I am creating a new property set style that I will be able to add to my proposed sewer manholes. You can create attributes that will help with asset management, such as who the manholes were installed by, the date of the installation, and the condition of the manhole when you might be inspecting it. These attributes can be applied to the manholes of choice. In this example, we are publishing as-built information for a city or municipality. This is just a small example of the data that can be added for asset management and can be added upon at any point. This example is as if I'm publishing the as-built information for this project. And as you can see, when going through the publishing process, there are no additional steps to get the data we added to publish. Just by using the typical publish to ArcGIS command, all of the data will be pushed. Keep in mind though, if additional property set data is added in Civil 3D in the future, you will need to run the publish process again. After the publishing process is complete, you can take a look at the newly published as-built data in ArcGIS Online and verify that the attributes have been included. The next set of videos, you will see the order and time of when this functionality was added to Infraworks and Civil 3D. Highlights from the Civil 3D 2020.1 video are the Autodesk connector for ArcGIS is introduced to Civil 3D. We'll be utilizing the pipe schema mapping to create gravity pipe networks in Civil 3D. We're able to edit GIS data and save back to ArcGIS Online from Civil 3D and publish to ArcGIS from Civil 3D. Inside of Civil 3D 2020.1, you can now access ArcGIS Online directly inside of Civil 3D via the connector for ArcGIS. With the connector, you can streamline the population of rich GIS data directly into your design environment, which will help you to make design decisions for your project. You can quickly select how you want the data represented inside of Civil 3D. With pipe network schema mapping, you can map attributes from the GIS data attributes to populate in your pipe network. When working with your GIS data, you want to be sure that you are working with the most current information. The connector keeps that live link to the data when updated in ArcGIS, but now you have the option to make changes to that data in Civil 3D and perform a save back to ArcGIS. In this example from our high-resolution image, we can see that the manholes might not be located correctly. You can update the location and then save back to ArcGIS. This updates the information in ArcGIS Online. Having rich GIS data is key when moving into the design of your project. It helps the civil engineer to make better design decisions, such as horizontal and vertical alignment of new utilities. During the process of design, when the design is approved, through construction, and when as-builts are created, this data needs to be updated at all stages of the project to reflect the latest information. Now with the ability to publish to ArcGIS Online, you can take advantage of the live link to data and ensure that not only existing conditions data is up to date, but all stages of the project data is up to date and can be accessed by all stakeholders. Moving on to Infraworks 2020.1, some of the new functionality included was change feature class of newly created objects, save back to ArcGIS Online from Infraworks, and publish to ArcGIS Online from Infraworks. One of the new features in Infraworks 2020.1 is the ability to add a new feature in the context model and then change the feature class to match a data source that you've already added from ArcGIS Online. In this example, we need to add a proposed water main to service the rear of the project for fire protection. After we've laid out the location, we can then change the feature class to a feature layer that we have in ArcGIS Online that represents the proposed water line layout for our project. This lets all stakeholders take advantage of the live link to your GIS data. Not only can you save back the location, but you can add attribute data that is also saved back to ArcGIS Online. Another new feature in Infraworks 2020.1 is the ability to publish information from your context model directly to ArcGIS Online. This same information can also be published to a portal. The user has control to define the area that they would like to publish by manual selection or select to use the entire model. This selection process applies to the feature types being published also. You can control the category and feature layer naming for the information being published and add specific tags so that the information can be searched for more efficiently in ArcGIS Online. You can also select who you would like to share this new data with before publishing. That ensures that the right people are able to access this published data. Once the data is published, all stakeholders will be able to take advantage of the information in ArcGIS Online. In Infraworks 2020.2, some of the new features that were introduced were being able to export to a file geodatabase for use in ArcGIS Pro from Infraworks. You could select specific attributes to export in that file geodatabase, and you can select specific attributes to export to ArcGIS Online also. There are times when you are sharing your GIS data with stakeholders that you might not want to include all of the attribute data associated with a specific data source. One of the new features in Infraworks 2020.2 is focused on solving this problem and adds the additional functionality for the Autodesk connector for ArcGIS. Now in Infraworks, when exporting a file geodatabase for use in ArcGIS Pro, for example, you have the option to select specific attributes from the data you're publishing instead of exporting all of the attributes at one time. This gives a user more control over what is being published. In this example, I could have sensitive information that I need to have access to internally for this sanitary sewer system, but maybe don't want to distribute all of the information to export to everyone. When the file geodatabase is added in ArcGIS Pro, only the specific selected information will be available for the assets. Not only is this functionality available when exporting a file geodatabase, the same functionality is available when publishing information to ArcGIS Online. It is also available if you're publishing data to an ArcGIS portal. This new feature ultimately gives the user the ability they need to deliver only the attributes they want to share when distributing any of their GIS data. At global launch of product year 2021, only Civil 3D had new features. The new feature to highlight would be object properties output as ArcGIS attributes. One of the new features in Civil 3D 2021 focuses on object properties when publishing to ArcGIS Online. In this example, a user has as-built information for a sanitary sewer that they would like to publish to ArcGIS. When a user publishes data, you want to be able to filter out any sensitive data that might not need to be public. Now when you publish data, you can select only the key data that you want to publish to ArcGIS instead of all the data at once. In Civil 3D 2021, all of the data that was assigned to the pipes is available for publishing, and you can edit the category names to customize the attribute fields when published. This gives the user more control over not only what attribute data they want to publish, but also how it will be represented in ArcGIS Online. Once the publishing process is complete, you can view the newly published data in ArcGIS Online. Inside of ArcGIS Online, when the same pipes are selected, you can see that the desired data was published with the custom field attributes. In the .1 release of Civil 3D 2021, More features were added, including curve support when exporting to file geodatabase from Civil 3D, edit ArcGIS attributes directly inside of Civil 3D, and then move newly added features to an ArcGIS later. In Civil 3D 2021.1, there have been several new features added around the Autodesk connector for ArcGIS. Now when you export a file geodatabase inside of Civil 3D for use in ArcGIS Pro, Civil features like alignments, for instance, that have curved geometry are represented as true curves and not tessellated line work. Another enhancement that's been made is the ability to edit attribute properties of an ArcGIS object directly inside of Civil 3D and then save back the edits to ArcGIS Online. This gives the user a more efficient way of updating rich GIS information. Any attributes that were edited directly in Civil 3D are now available in ArcGIS Online. Now also in Civil 3D 2021.1, a user can add additional information to an existing ArcGIS layer and then save back that information to ArcGIS. Once the desired geometry is in place, you now have the option to move the selected geometry to an existing ArcGIS layer. If you take a look at the properties, you can see that all of the attribute entries from the existing ArcGIS layer have been added to the newly created geometry. With the same set of attributes now on our new geometry, a user can then populate the attributes directly inside of Civil 3D. When a save back is performed, all of the new geometry added and added attribute information will update the feature layer in ArcGIS Online. This gives the user great flexibility in creating, updating, and managing GIS data. In the latest update for Civil 3D 2021.2, new features for the Autodesk connector for ArcGIS included raster layer support for imagery in Civil 3D, raster layer support for terrain data in Civil 3D, and then refresh existing data layers in Civil 3D. New inside of Civil 3D 2021.2 is the ability to bring in raster imagery from ArcGIS Online via the Autodesk connector for ArcGIS. In this example, I will use an image that covers the entire state, but I will only use a small section of that image. You have two new feature types to choose from inside the dialog, imagery and surface. You have the option of selecting a predefined resolution, or you can simply select the source resolution. You can repeat this process if needed and have multiple images at different resolutions. In addition to being able to bring in raster imagery from ArcGIS Online, you can also utilize terrain data from a raster layer in ArcGIS Online that will create a surface for you in Civil 3D. You again have the option to select an image resolution or use the source resolution of the raster data. Once applied, a surface is created for you in Civil 3D. Another new feature in Civil 3D 2021.2 is the ability to refresh existing layers from ArcGIS Online that are already being utilized inside of your Civil 3D model. Refresh will allow us to quickly retrieve the latest information from ArcGIS Online. So when a change is made to the data, in this example, a manhole was not in the right location, you can take advantage of the live link to the data to be sure that you have the latest information available to you in your model. Inside of the Data Source Manager, you can select the data sources that you would like to refresh, and the connector will fetch the latest information and quickly update your model. Now, let's change our focus to Map 3D. I will take you through connecting to data in ArcGIS Online and then saving back to ArcGIS Online any changes that we have made to the GIS data. The process to connect to the data is much the same, but you will use traditional Map 3D workflows and functionality to save back. Let's take a look. Inside of Map 3D, you can access the connector for ArcGIS, and the experience is much like the experience that you have in Infraworks and Civil 3D. To show the functionality, I will go back to Littleton, Colorado, and we will connect to the existing sewer information from the city that is housed in ArcGIS Online. In this familiar dialog, we can preview the information that we want to bring into our model. Now we are ready to add this information to our project in Map 3D. Once the information is added, we might want to stylize the manholes in the sewer line differently than it is shown. We will start off by modifying the manholes, changing them from a rectangle to a circle. We will also change the fill color to red. On to the pipes. All I want to change here is the color of the line. We will change it to red. You could also access custom line types if you have them available. Using typical Map 3D workflows, you can select one of the pipes and show the data table. The data table allows you to see the information for all of the pipes, and if you select one of the pipes in the data table, it highlights for you. We can also edit the GIS attributes in the data table. With our edits complete, you simply check in the edited features. When you use the check-in feature in Map 3D, the live connection to ArcGIS Online updates the attribute information inside of ArcGIS Online. To complete the workflow, if any of the attribute information is modified in ArcGIS Online, then we will get that update in Map 3D with a simple refresh of the data. Notice that the inside diameter change that we made in ArcGIS Online is now reflected in my model. If I need to move any of the geometry, I can select and check out that geometry and then move it to the desired location. I would again use the check-in feature from Map 3D to update through the live connection to ArcGIS Online. And with a simple refresh of my web browser, I can see the change. In Map 3D, I can also add additional line work to my drawing and push that line work back to ArcGIS Online. In this case, I will add a couple of sewer pipes and manholes. In the map workspace, I can select the feature layer I want to add to, right-click, and select New Feature from Geometry. Then select what I would like to add. Once added to the feature layer, you can open the data table and start to fill out any and all of the attributes that have been added to the line work. The same thing can be done with the manholes. The manholes that are shown are just AutoCAD blocks. You can select New Feature from Geometry and pick the block the same as you did with the line work. And again, you can edit in the data table any or all of the attributes that are shown in the data table. When you are ready, you can select Check In from the ribbon and it will push the changes to ArcGIS Online. If you would like to disconnect from the feature layers in ArcGIS Online, simply select the feature layer or feature map name in the map workspace, right-click and select Remove Layer, and you are disconnected. So let's switch our focus and return to the state of the integration slide and focus on what Esri has been delivering in the area of product to product and product to platform. Esri's initial focus was on enhancing capabilities that provide better access to data created in design. One area of focus for them was the ability to directly read Revit models into ArcGIS Pro. ArcGIS Pro reads the source data and dynamically interprets it as if it's a collection of GIS feature services without changing the source file. It is a great way to spatially manage a group of individual assets and can also be used to tell a project story to stakeholders over the web. GIS users with this capability have said that it provides visibility into models across a large geographic area in a familiar, easy to use way with a drill down access in browser-based secure environment. It enables the merging of disciplines to see the full picture of a project, or a grouping of assets, which brings operational and transparency gains. What Esri added in July of 2020 was the ability for GIS professionals to access design models, including Revit files, Civil 3D models, and basic AutoCAD drawings, directly from within BIM 360 and Autodesk BIM Collaborate Pro. Team members will now know where data is and how to find it. They'll know they are working with the most current information, as they have a direct connection to the information the engineering and design team is creating. Let's return to the state of the state integration slide and focus on what Esri's been delivering in the area of product to product and product to platform. Now let's talk about the coming soon. They're also working on platform to platform. It's a solution that is coming soon called ArcGIS GeoBIM. ArcGIS GeoBIM is all about connecting the platforms. Esri is creating GeoBIM web apps that create the connection to BIM 360 and the Autodesk Construction Cloud. This enables a user to utilize mapping and visualization, look at engineering documentation, utilize project issue dashboards, visualize the project progress, be collaborative with issue management, and create and resolve issues from GIS. This video was developed in cooperation with Autodesk. What this video demonstrates is the powerful integration solutions that can be built using Esri's web services in the Autodesk Construction Cloud. What this shows is the frictionless, live, and native data access between platforms. This web app connects project and asset information managed in BIM 360 or the Autodesk Construction Cloud to ArcGIS in a way that helps solve the problems the industry is facing in working with potentially huge data that may only be needed by certain people at certain times. The video demonstrates that it was possible to provide access to live BIM models from within an easy to navigate spatial environment, connecting project delivery to O&M. I would like to thank you for participating in the class today and wish you a great rest of the day.